we can always do better. And I'm going to tell you what I think we can do better and what's probably coming in the future. Greg mentioned yesterday it's our 30th year at Bentley Systems, so I thought I'd start by looking back over those 30 years and sort of making some observations about patterns that have happened over those 30 years. And the objective there is not to reminisce, but instead to look at what probably is going to happen next. And what I've observed over 30 years is that innovation happens in waves. And hardware changes drive lots of new things. And what is interesting about that is we're at the cusp of a very new and, I believe, exciting new hardware revolution. So I'm going to talk a little bit about what that will likely mean for us, and I'll wrap up by telling you what I think that means for Bentley's products and what we're going to start working on, what will become important over the coming few years. I thought I'd start. I said I was going to look back over our 30 years, but what would it be like if 30 years ago we had looked back 30 years before that, so 60 years ago? And I managed to find a picture of the computing industry of 1954. I have absolutely no idea what this computer did, but I assure you it was expensive. And I can also assure you that the computer in your pocket, that we now call a phone, is far more capable on every dimension than this computer ever was. So 30 years after that, the personal computer was born. And with it, Bentley Systems was born, Microsoft was born, Autodesk was born. That wave of innovation where you took what was a big computer and turned it into a small computer provided a tremendous amount of opportunity for us to solve problems in different ways than they had been done before Bentley existed. A few years later, the personal computer gave way to the personal workstation. 16-bit computers became 32-bit computers, and 2 to the 16th is a much smaller number than 2 to the 32nd. I can assure you, programmers take a tremendous advantage of the capabilities offered by lots of more memory. I think probably the biggest distinction between the personal computer and the personal workstation was we had a network, and you could connect 2 computers to get 2 workstations together, whereas the personal computer was an isolated island of productivity. Then, a few years later, this little thing called the Internet happened, and with it were born companies like Google. You may have heard of them. And a lot of new ideas were spawned. And frankly, the way we wrote software changed pre-Internet to post-Internet. So what you observe is hardware changes have driven innovation in software, and then software kind of matures and it provides opportunity for people to innovate hardware-wise, and the cycle repeats. I will point out that oftentimes the ideas that turn out to be the greatest ones start out as little improvements over past practices, and I think that is likely what will happen going forward. I'll also observe that waves are not, we don't have a meeting and say, let's have a new wave. They just happen. And they become apparent sort of after the fact. So if you look back 5 years ago, I don't think most of what we were talking about here today would have been possible. It wouldn't have been the architecture required to do that, infrastructure required, computing infrastructure required, wouldn't have been possible. So it isn't that there's only one wave at a time, there's overlapping waves. And the current wave, I think, is going to be a very big wave. Another thing I'll observe is software engineers, like every engineer, makes trade-offs. And the trade-offs that you make in designing a piece of software has to do with the resources available to you. And if computing resources are expensive, you do things to make optimize for what's expensive at the cost of something else which might come cheaper. So those trade-offs are kind of incorporated into the design, and they're created at the time that the software is conceived. So these waves kind of bring about generations of software. And what we see is that a couple of waves after its birth, software needs to basically be redone. And that, unfortunately, is what's happened. If I look at what the hardware industry caused, if we look at the problems that we tried to solve, I'm not just talking about Bentley, but the infrastructure software industry at large. In the beginning, with the personal computer, our mission was easy. Well, in retrospect. It was easy. All we wanted to do was automate the process of creating pieces of paper. In fact, the definition of right was if you couldn't tell that the piece of paper was created on a computer from what a person would have drawn by hand, we got it right and we got paid for that. That was our goal. A few years later, when the workstation was born, we thought, well, you know, pieces of paper, just automating the process of pieces of paper. In fact, we used to call it CAD, Computer Assisted Drafting. That was our market at the beginning. When the workstation came along, we said, you know what, we can do better. We can design things in 3D. In fact, instead of just automating the process of creating the same pieces of paper, we can automate the process of design. And we can actually create things that are better designs because they were done on the computer. And we call that CADD, Computer Aided Design and Drafting. And that was our mission for quite a while. And the difference between mission 1 and mission 2 was we stored some additional information on the graphics, but the data types basically centered around the physical representation of the thing we were designing. Then the internet was born, and with it, the BIM era was born, and of course everyone knows BIM stands for Bentley's Information Modeling.
That was a strong one.
I liked Andrew Norton's definition yesterday, where BIM is more about the process, because I think that really is a better description of what people think of when they mean BIM. And I agree with him wholeheartedly, but when you talk about what the actual software does, most of what BIM products do today is automating the design process. It was conceived from, you know, the starting point of CADD, and we figured out ways that you can, by giving something some property, some additional behavior, we can derive drawings from the 3D model, keep them synchronized, and so forth. But Andrew yesterday talked about something, and he said, our mission is to create something that's going to last 150 years. And I can assure you, that was not in the design spec then. That change order is pretty significant. And while he's right about that, as I was listening to him, I was nodding my head in case anybody was looking, but I was thinking, uh-oh. We've got a lot of work to do. And I think the goal of BIM and the objectives that Andrew described positively are what should be working. But that isn't exactly the way the software of today's generation. I refer now to our software and our competitors' software as well. It wasn't designed for that purpose. So let's talk about how we can do it differently. Well, today, you'll observe that the hardware of 2014 is substantially different than the hardware of 2009, let's just say. I actually found a picture of the hardware of 2012. This is a Google data center, probably the most advanced data center of the time in 2012. And you notice that back to 60 years ago, it was completely different. We determined that the glass should be on the left. Anyway, let's talk a little bit about hardware. The first thing that everyone knows in 2014, because you're inundated with it, is a concept that I call server for hire. And the concept is that a company like Microsoft can afford to build a data center so large, and they can modularize computers so small that they can afford to have racks and racks and racks of them, and they can afford to supply the power to them, the cooling to them, the networking to them, the disk drives for them, and make that all so economical that they can afford to rent them to you cheaper than you can buy them yourself. And that is really kind of a cool proposition, I think. One of the reasons why it's more economical is if Microsoft buys them or Amazon buys them, you don't have to decide how many of them you want. Because if you want more of them on a weekend than you want them during the week, you pay them incrementally. And that's a crazy, amazing to me anyway, idea. I've heard about the idea for many, many years, and I've always been a skeptic of it, but you cannot argue that they figured out how to do it, and Microsoft do it pretty darn well, I think. Another hardware innovation, maybe not quite so grandiose, is radios. It isn't that radio waves move faster in 2014 than they used to. They move exactly the same, of course, but we are distributing the bandwidth differently, and what mostly has happened is there are more radio transmitters. If you look around the little blue lights, those are radio transmitters. And the reason that's important is because we now can presume anywhere we are that we can always get a data connection. And that's pretty important. Another thing that is important is batteries. Now, batteries don't evolve quite as quickly. There's no Moore's law of batteries. But you can certainly say that the batteries of 2014 are certainly better than they were in the past. And one of the reasons why battery technology is so important is we sort of here describe personal or portable mobile computers as being a given. But remember, the iPad was only invented in 2010. Right? So there are only 4 years that mobile devices have really been mainstream at all. But they wouldn't have been possible without batteries and something else that is disk drives in mobile computers today. They're now a solid state drive rather than a spinning drive. Had that technology not been available, there would not be a mobile computing revolution as exists today. Another thing that I'll point out is graphics processing. Graphics processing has advanced tremendously. Why? Because kids use it in games. That's why. But a graphics processor is an amazing computer. It goes to waste unless you do lots of very advanced things that could be now in games to take advantage of it. And my last issue with hardware, my last point about hardware is sensors. Not just things like temperature sensors and pressure sensors, but all kinds of sensors like GPS sensors, I'll call a camera type of sensor. And all those things now, they've miniaturized them and made them amazingly accurate and affordable. On the software side, well, the computer for hire wouldn't be quite so appealing unless there was some way that you could use it, and people like Microsoft have worked on things they now call Azure. And it's a really cool technology for figuring out how you make these servers for hire secure and reliable and scalable, all the things that you might need in order to write software that runs on a cloud computer. So you've probably been inundated with descriptions of the cloud computer. Another thing I'm sure you've been inundated with is descriptions of something called big data. And big data is a really interesting new concept, but it isn't just about the magnitude of the data. People often think of big data as meaning just something that is a large number of records or something. If we had a database of the cell phone number, name and cell phone number of every person on the planet, that would be a big database. But it would just be a database. It wouldn't qualify what I think of as big data. If instead you had a desire to know the current location of every cell phone on the planet, that would be big data. And if you wanted to track the movement of cell phones, you couldn't take a normal database approach for it. It wouldn't work. If you had one server that had to collect all that information, it would quickly be inundated. So you need to have a distributed data model, and you need to have a distributed processing model. And people have come up with very creative and cool new ways of having multiple computers working on a distributed problem. And that's called big data. I call it fast data, but nobody agrees with me. But if you hear big data, Keith said fast data. All right, and another thing I won't spend any time on, everyone knows it, is social computing. The way that people interact with one another is through some kind of a hidden server somewhere with a service like Twitter or Facebook or something like that. And obviously, if you can do it for just personal communications, you probably want to be able to do it for business communications as well. So we need to work on that, things like that. Another big factor in software is operating systems. Every one of these devices works a little differently than the old computers of desktop computers. The iPhones have one operating system, Androids have a different type of operating system, Windows mobile devices have even a different one. So now that influences the way that we create software, and we're having to take that into consideration. Another concept I'm sure you've heard of is the Internet of Things, and it's an interesting idea, but it's not all that radical, frankly, when the concept is every computer doesn't have to look like a computer. computer. If you put a computer like Trimble does on a bulldozer, that can be a node in a network. And if you put a sensor on traffic lights or on street traffic patterns, they can also provide real-time information, and that can be what I call fast data. So the techniques for modularizing what we previously would have called a computer and put it into a form factor that doesn't actually look like a human should use it, that's a really cool new technology called the Internet of Things. So what's this going to do for us? Well, if you think about the problem of a 150-year data model, we need to think differently, and I'm convinced the way to think differently is to think the same as they do in other businesses. The typical way that a business application is constructed is you offer a data model and then you create tables and ways that people query that data model. But the current BIM model doesn't work quite the same way. And so I think we need to think the way that the business world thinks for our model information. Now, when Andy McNaughton talked about the way they're building their BIM models, he said they're going to build the physical thing, they're going to build the virtual thing. And I also believe he's got a point there. I think what we need to do is to make ways that the physical thing and the virtual thing kind of look the same when you're trying to answer questions about what's in there. And so I'll call one side of that the model world. That's the stuff we tell it what it looks like. And then there's the physical world, which we observe what it looks like. And you can observe it in lots of new and different ways. And we're going to show you some. But just take, for the example, you take lots of photographs of something, and from those photographs you can infer information, and then you want to combine that information with the model world. You do not want to think about the boundaries of the physical world and the model world. And we need to